Hello everyone. Ang ating discussion in our today's session is all about high strength concrete. And to start with, kailangan muna nating ibigay ang definition ng concrete. Ano nga ba ang ibig sabihin ng concrete? Concrete is actually a composite material that consists essentially of a binding medium within which are embedded particles or fragments of aggregates. What is concrete again? Another definition, in concrete construction, the Portland cement concrete is utilized as the most widely used construction material in the world. Thus, concrete is generally an artificial conglomerate stone made essentially of Portland cement, water, and aggregates. Yan ang pamamaraan para tayo ay makabuo ng isang konkreto. Why concrete is popular? Bakit nga ba? Una sa lahat, economical. Lalong-lalo na kapag ang konkreto natin ay inaluan natin ng iba't ibang mixtures, just like plasticizers, accelerators, and so on and so forth. Energy, ability to work with reinforcing steel, ambient temperature, ardent material. It has the ability to consume waste. Isa pang dahilan kung bakit napaka-popular, excellent resistance to water, high temperature resistance. At yan ang mga dahilan kung bakit ang konkreto ay napaka-popular sa construction industry. Less maintenance required. Now, meron tayong iba't ibang klase ng konkreto. Ito na muna ang ating tatalakayin dahil maliban sa tatlong yan ay meron pa tayong iba't ibang klase ng konkreto. Basically, aralin muna natin ang ating tinatawag na normal concrete, high strength concrete, and high performance concrete. So ano nga ba ang kaibahan ng tatlong yan? Magsimula tayo sa normal concrete. Concrete in which common ingredients are used. Strength between 20 to 40 megapascal. This type of concrete are actually classified as or categorized as normal concrete. Water cement ratio is between 0.45 to 0.60. Most common use in the market and readily accessible to the client's usage. It is mostly used in the home environment to undertake construction projects. Not recommended for construction work in severe weather condition. Normal concrete are limited to mid to low-rise buildings. Kapag normal concrete ang pinag-uusapan, pumapasok sa ating kaisipan na mga mid to low-rise buildings yan. So hindi tayo pertaining to the high-rise. So hanggang mid to low-rise buildings lang. Just like yung bungalow, two-story na unit ng residential, and so on and so forth. Huwag lang aabot sa matataas na gusali. Now, kapag high-rise at saka bridges na ang pinag-uusapan, okay, for our introduction, high-strength concrete may be defined as concrete with specified characteristics. Cube strength of 60 to 100 megapascal and even higher mainly compressive strength. So kapag high-rise building natin na ang ating pinag-uusapan, or let us say mga bridges, dapat ang type of concrete or kategorya na ating gagamitin is high-strength concrete na. So hindi na pwede dito yung normal concrete lamang. Other reference define it having a strength of between 40 to 140 megapascal. Kapag lumampas daw ng 40, ang strength or ang compressive strength ng konkreto, it is already classified as high-strength concrete. Strength of levels of 80 to 100 megapascal and even higher are being used for both precast and in situ work in many countries. The main application for HSC, in situ concrete construction, are in offshore structures, columns for tall buildings, long span bridges, and other highway structures. The main advantage is actually the reduction in size of compression members and or the amount of longitudinal reinforcement required. So kapag malakas ang tipo ng iyong konkreto, maaari mong liitin ang structural members. In the first place, kapag tumataas ang gusali, dapat ang structural members natin ay lumiliit ng bagya para sa earthquake safety natin. High strength concrete again. So yan, mayroon tayong nakikitang high-rise building kung saan ang structure na yan was actually constructed and made by high-strength concrete category or type of concrete. Meron din na mga pavement na kailangan ay high-strength concrete ang pagkakagawa kapag ang mga dumadaan dyan ay mga heavy vehicles na or let us say heavy machineries. High-strength concrete is made by lowering the water-cement ratio. Kailangan ang water-cement ratio natin is 0.35 or lower. 0.35 or mas mababa pa. Isa yan sa dapat nating tandaan para ang konkreto natin ay ma-qualify sa pagiging high-strength. Often sticky and also found difficult to be handled and placed due to high cement content. Does not bleed compared to normal concrete. So kailangan wala tayong bleeding na nakikita sa ating high-strength concrete or mixture of concrete. Which cement is used in high-strength concrete? Ano nga bang semento ang ginagamit natin dito? Kailangan ang grade ng semento ng ating Portland cement is 43 grade or 53 grade that can be used in the production of high-strength concrete. What's the difference between regular concrete and high-strength concrete? Concrete is used as construction material and it is categorized as normal concrete or high-strength concrete based on its compressive strength. The compressive strength of normal concrete is between 20 to 40 megapascal. And exceeding to that, 40 megapascal, pwede na nating tawaging high-strength concrete or as long as napapalo yung minimum requirement para maging high-strength concrete. The strength of high-strength concrete is above 40 megapascal. As we can see here, we have a universal testing machine. Ito yung ginagamit nating aparato para ating matest ang ating sample concrete kung ano ba ang compressive strength nito. As we can see, we have a sample concrete here. Yan yung ating itetest. And then, dito malalaman natin kung anong kategorya ng ating sample ng konkreto gamit ang universal testing machine. By the way, ang gamit ng universal testing machine, hindi lang yan sa pagtetest ng compressive strength but also the tensile strength of rebars. So kailangan ng compressive strength para matawag nating high-strength concrete. Mas maganda kung 60 megapascal or greater. Hindi lang yung 40 megapascal and above. So ito yung sample ng concrete, cylindrical concrete na naporma natin gamit ang cylindrical mold na may diameter na 150 mm at Ang standard size niya, depth is 300 mm. Kapag ginagamit natin ang UTM, ito yung maaari natin gamitin standard size of sample ng concrete mixture natin. And of course, we have the other one, may diameter na 100 at saka depth na 200 mm na cylindrical mold or cylindrical concrete sample. Does high-strength concrete have more cement? The high-strength concrete has a lower value of permeability compared to normal strength concrete. This is one reason. This is because the high-strength concrete is designed with lower water-cement ratio. Note, high-strength concrete is made by lowering the water-cement ratio 0.35 or lower. As we can see here, high-rise buildings. And of course, we have also bridges, long-span bridges. Yan yung mga produkto na maaari nating makonstruct gamit ang high-strength concrete. What is high-strength concrete used for? Yeah. So yan ang gamit niya. High-strength concrete is typically used in the erection of high-rise structures. It has been used in components such as columns, especially on lower floors where the loads will be greatest. Shear walls and foundations, high strengths are also occasionally used in bridges application as well. Mas magandang gamitin ang high strength concrete sa pundasyon para matatag ang gusali na ating itatayo. Specifically, yung mga poste natin, kailangan made of high strength concrete kung tayo ay magtatayo ng matitibay na bridges or tulay. And of course, high-rise buildings. Why high-strength concrete is required for prestressing? High-strength concrete is necessary for prestressed concrete as the material offers highly resistance in tension, shear bond, and bearing. High-strength concrete is less liable to shrinkage cracks and has lighter modulus of elasticity and smaller ultimate creep strain, resulting in a smaller loss of pre-stress in steel. Does high-strength concrete cost more? In reducing the amount of materials required, costs are also reduced, which in turn makes high-strength concrete one of the most economical methods of vertical load bearing. How long does high early strength concrete take to cure? For most concrete structures, the curing period at temperature of above 5 degrees Celsius or 40 degrees Fahrenheit should be a minimum of 7 days or until 70% of the specified compressive or flexural strength is attained. And even in actual construction, bago mo ipagpatuloy ang pagbubuhos, say for example, tapos ka na sa poste, gusto mo na magbuhos ng beam. So kailangan mo muna maghintay ng ilang araw hanggang mamit na ng column ang kanyang specified compressive or flexural strength kapag ito ay kanya ng na-attain. Actually, the period can be reduced to 3 days if early strength concrete is used and the temperature is above 10 degrees Celsius and 50 degrees Fahrenheit. Actually, tinitingnan talaga ang temperatura ng konkreto sa mga malakihang construction firms in actual ng mga engineers. Materials used for high-strength concrete. The methods and technology for producing high-strength concrete are not substantially different from those required for normal strength of concrete. Kailangan ng tubig malinis, sariwa, at walang contamination. Walang acid, free siya sa contamination. Yun ang kinakailangan sa tubig na ating gagamitin kapag tayo ay naghalo ng konkreto. The target water cement ratio should be in the range of 0.30 to 0.35 or even lower. Kailangan mas mababa para mabilis ma-attain ng ating konkreto ang kanyang required strength or compressive strength. Cement, all types but low C3A cements are desired since they generally provide concrete with improved technology. Cement content should be below 500 kg per cubic meter to avoid excessive increase in brittleness and reduce the material cost of concrete. So hindi pwedeng cement alone lang. Kailangan meron tayong mixture na aggregates. Kung hindi, mas lalong magiging brittle ang concrete. So kailangan inaaluan din yan ng mga admixtures na pinatawag natin. Let us say we have the blast furnace slag, fly ash, silica fume. Ito yung ginamit ng mga Indiano sa pag-construct ng sample ng concrete na qualify as high-strength concrete. It is actually the byproduct of producing silicon metal. Very reactive pozzolan din yan. Actually, meron tayong tinatawag pang Silicon Valley of India kung saan may maraming silicon and natural pozzolans, etc. to reduce the production cost of concrete and tackle the slump issues. So ito yung itsura ng silica fume. Isang uri yan ng admixtures na ating inaalo sa ating konkreto. Then we also have this C3A. Yan ang ibig sabihin ng C3A na ating nabanggit kanina. Ito ang tinatawag nating tricalcium aluminate. It is actually one of the main constituents of Portland cement. Gypsum is added to regulate this reaction and preserves the workability of the cement paste at early ages. The understanding of the C3A gypsum reaction is therefore crucial for the comprehension of the early hydration of cement. Paano ba nabubuo ang C3A sa semento? Okay? How is C3A formed in cement? Properties. Pure tricalcium aluminate is formed when the appropriate proportions of finely divided calcium oxide and aluminum oxide are heated together above 1,300 degrees Celsius. Why C3A? It liberates a large amount of heat during the first few days of hydration and hardening, and also contributes slightly to early strength development. So napakalaki ng ambag nito para mapabilis ang development ng konkreto. Gypsum added to the cement slows down the hydration rate of C3A. Cements with low percentage of C3A are especially resistant to soils and waters containing sulfates. So alam na natin ngayon kung bakit mahalaga ang C3A. Kung bakit nga ba C3A? The material used for high-strength concrete, these are the following, but of course we have the aggregates. Kailangan ang aggregates natin well-graded coarse and fine aggregate. Huwag nating pipilingin yung rounded na aggregate pagdating sa coarse aggregate kasi mapino yun. Walang binding ability masyado yon. Unlike yung angular na type ng coarse aggregate, yun ang magandang gamitin. Coarse aggregate, crushed rock aggregates of suitably high crushing value are preferable. Generally, the maximum aggregate size ranges from 10 to 20 mm up to 28 mm. For compressive strength of 70 megapascal, ang kailangan nating aggregates, kailangan nagre-range ng 20 to 28 mm. Kung kailangan nating ma-reach o kung gusto nating ma-reach ang strength na 70 megapascal. Pero kung 100 megapascal naman, kailangan ang maximum aggregate size are ranging from 10 to 20 millimeter naman. So, habang lumiit, mas lalong nagiging okay. For compressive strength of 125 megapascal, maximum aggregate size ranges from 10 to 14 millimeters. Kung napapansin natin, habang lumiliit ang coarse aggregate, yung ranges nila, mas lumalakas ang konkreto. Mas nagiging qualified sa pagiging high-strength concrete. Fine aggregates within a fineness modulus of about 3.0 give the best workability. Paano natin malalaman yan? Di gamitan natin ng sieve analysis. Pero naman tayong sieves na makikita sa laboratory at pwede namang ipatest ang ating aggregate. Well-graded aggregate helps in reducing the quantity of paste, that is, the weak link in a mass of concrete, increase economy and improve unit weight and the interfacial bond. And then we also have the chemical admixtures. Superplasticizers or high-range water reducers should be used to achieve maximum water reduction. The reduction of water content BU to 30%. Now, for the strength enhancement, concrete strength enhancement can be achieved through the use of superplasticizer admixtures. That is to produce a low water cement ratio, giving high performance concrete. So iba na naman yan. Meron na naman tayong tinatawag na high performance concrete. So ito yung itsura ng superplasticizer. Actually, nabibili yan sa mga construction supplies. And of course, we have also the super slump buster. These admixtures promotes high slump, extremely flowable concrete that achieves high strengths while providing superior workability and pumpability. Actually, yung slump, pagdating sa material and testing, tinetest din natin yan at sinusukat din natin yan. At meron din tayong iba't ibang klase ng slump. Ito kasi makakatulong natin sa early works para alam natin ang direksyon ng ating konkreto. Kung ito ba ay maayos, matatag, matibay, mas malakas yung konkretong ating nililika. So ito yung ating makakatulong. Yung pagtingin kung ano ba yung uri ng slump meron ng ating sample concrete during the mixture process. High-range water reducing admixtures can also be used for precast, prestressed structures where it is desirable to keep the water cement ratio to a minimum for low permeability and high early strengths without set retardation. And they are also used for concrete requiring high early stripping strengths. Fly ash, making concrete stronger, more durable, and easier to work with. That is fly ash. It is derived from burning coal, and fly ash is a valuable additive that makes concrete stronger, more durable, and easier to work with. Fly ash aids the formation of cementitious compounds to enhance the strength, impermeability, and durability of concrete. Now, we have two main classes of fly ash that are used in concrete. First, we have the class F. Second one, we have the class C. For the class F, ano nga ba yung class F? It reduces bleeding and segregation in plastic concrete. In hardened concrete, increases ultimate strength, reduces drying shrinkage and permeability. It also lowers heat of hydration and reduces creep. For the class C, however, it provides unique self-hardening characteristics and improves permeability, especially useful in prestressed concrete and other applications where early strengths are required, also useful in soil stabilization. Then we also have the silica fume. for early strength and reduced permeability. Silica fume can make a significant contribution to early stage or early age strength of concrete. A 1 pound of silica fume produces about the same amount of heat as a pound of Portland cement and yields about 3 to 5 times as much compressive strength. Improves concrete in two ways: the basic pozzolanic reaction and a micropillar effect. Addition of silica fume improves bonding within the concrete and helps reduce permeability. It also combines with the calcium hydroxide produced in the hydration of Portland cement to improve concrete durability. What else? As a micropillar, the extreme fineness of the silica fume allows it to fill the microscopic voids between cement particles. This greatly reduces permeability and improves the paste to aggregate bond of the resulting concrete compared to conventional concrete. Again, under ng silica fume, so ito yung ating dosage na kinakailangan kapag ito ay ating gagamitin. 8% to 15% by weight of cement, but as an addition, not replacement. 8% to 10% for high durability or low permeability such as bridge, decks, or parking structures. Pero kapag high strength structural column naman ang ating pinag-usapan, kailangan 10% to 15% ang ating kailangan. Kapag flat work, 10% is already a maximum. The amount required is related to silica fume dosage and the water cementitious materials ratio. Silica fume is cementitious actually, but typically is added to and not replacing the existing Portland cement. So we have the tip. The higher percentage of silica fume used, the higher the amount of superplasticizer needed, but mix can become sticky. Considering replacing about 1/3 of the superplasticizer with a mid-range water reducer to improve workability. Ano yung gamit ng silica fume? Una, ang function nito is to reduce concrete permeability. Second one, to strengthen the concrete sample. Third one, improves resistance to corrosion. Concrete admixtures that control cracking, reducing drying or shrinkage cracking. Hydrated cement paste shrinks as it loses moisture from its extremely small pores. As the moisture is lost in these small pores, the surface tension of the remaining water tends to pull the pores together, which results in a loss of volume over time. SRAs are designed to decrease the effects of drying shrinkage by reducing the surface tension in these pores. It should be noted that the type of aggregate and the cement properties themselves can influence the amount of cracking that can occur. Thus, it is important to test local project-specific materials if doing shrinkage testing. Curing also affects cracking. In slabs, the top tends to dry out first and shrinks while the lower sections still have a higher moisture content. The difference in moisture can be altered by use of shrinkage reducing admixtures, which alter the way water migrates through the concrete and results in a more uniform moisture profile. Mineral admixtures are environmentally friendly as they reduce the emission of carbon dioxide, in addition to improve the properties of concrete. Fly ash, ground granulated blast furnace slag or GGBS, metakaolin, silica fume, and rice ash are the major mineral admixtures used in the constructions. So I repeat, we have the fly ash, GGBS, metakaolin, silica cube, and rice has as. For the advantage of high-strength concrete, let me enumerate them. First, the main advantage is the reduction in the size of compression elements and or the amount of longitudinal reinforcement required. High-strength concrete provides A, high compressive strength. Second one, high or higher modulus of elasticity, higher tensile strength, reduces creep, greater durability than the normal concrete if we're going to compare them. And how about the disadvantages of high-strength concrete? Most of disadvantages are due to lack of adequate research under field conditions. Damages at a high temperature, in example, less resistance to fire. Must be expertise in selection of ingredients. Kailangan alam natin yung mga ingredients natin na gagamitin kapag gusto natin makalika ng high-strength concrete. So kailangan meron ka muna expertise. So yun ang disadvantage. Concrete creep is defined as the formation of structure under sustained load. Kanina pa ninyo kasi naririnig ang creep. So yan ang ibig sabihin niya. Basically, as long-term pressure or stress on concrete can make it change shape. This deformation usually occurs in the direction the force is being applied, like a concrete column getting more compressed or a beam bending. For the modulus of elasticity of concrete, it is actually the measurement of the stiffness of the concrete, which is actually a good indicator of strength. At a higher value of modulus of elasticity, the concrete can withstand high stress and become brittle. In general, concrete has an elastic modulus in a range of 30 to 50 gigapascal. For the applications of high-strength concrete, yan, so makakalikat tayo ng matataas na gusali. Or we can have the erection of high-rise buildings. It has been used in components such as columns, especially on lower floors which has more load, shear walls, and foundation. Diyan napaka-importante ng gamit ng high-strength concrete. High-strength are also occasionally used in bridge applications. Some most recent includes parking garage, warehouse, and other highway structures. High-strength concrete is typically used in dams construction. Look at it, we have sample of a bridge here, and of course, a dam. So, ginagamit yan. Yan ang kailangan sa pagkukonstruct ng matitibay na tulay, and of course, dams. Sa Pilipinas, marami tayong mga dams na nilikha gamit ang high-strength concrete category na konkreto or mixture. We have the Angat Dam, Damagat Dam, and Ipo Dam, and napakarami niyan. So here is a sample of a ready-mix concrete specifications. So resulta yan. So dito na-classify yung konkreto na class B. And the cement factor, bags per cubic meter, 11 bags. The design strength is 6,000 PSI na pwedeng ma-attain or ma-achieve sa loob ng 28 days. And the maximum water cement ratio is 0.41. So parang mataas siya sa 0.35. No, ibig sabihin parang hindi ito high strength concrete kasi naalala ko kanina, nabanggit ko, kailangan 0.35 or 0.30 or lower yung water cement ratio na kailangan natin. Slump must be 6 to 8 inches. So yun yung design specification. And then as we can see here, yung fine aggregates, yung coarse aggregate, at saka yung mga kailangan mga resulta sa preliminary test data ay nandiyan. So sa finest modulus ay may 2.812, specific gravity is 2.616, absorption, the unit weight, and of course, the value of moisture. When it comes to cement, meron din tayong result sa fly ash and at the same time sa admixture test. So we have another result here. As we can see, the design per bag of concrete, nakapilap yan. So ganyan yung reporting na ginagawa kapag nag-eksperimento regarding about concrete samples. Then ice-strength concrete again, admixtures containing microsilica, or what we call also a condensed silica fume, are used to meet ice strength and low permeability requirements. Benefits include reduced permeability, increased compressive and flexural strength, and increased durability. Applications include ice strength structural columns, less permeable parking garage decks, and abrasion-resistant hydraulic structures. It can be used in concrete to produce compressive strength approaching to 20,000 psi under job site conditions. So kapag 20 psi na yan, 20,000 psi na yan, definitely ice strength concrete na yan. This admixture can be added in a slurry or in a dry form, whichever meets the batching equipment needs. In either case, performance is the same. What latest concrete technologies are available now at present? Producing high-strength concrete mixed with minerals and chemical admixtures. So these are the mineral admixtures. The fly ash. Again, I repeat, na-mention ko na kanina yan, silica fume, metakaolin, fly ash, ground granulated blast furnace slag. And for the chemical admixture, we have the superplasticizers, water-reducing agents. And of course, we have the accelerators. So we have the type of admixtures na tinatawag nating accelerators under ng ASTM C494 and ASTO M194 type C. Ang desired effect nito is to accelerate setting and early strength development. The material is actually the calcium chloride, triethanolamine, sodium thiocyanate, calcium formate, calcium nitrite, and calcium nitrate. So yun yung mga materials ng accelerators natin. How to choose an appropriate concrete technology with respect to the following aspects: economy, safety, practicality, manageability, and of course, we have to do the following process: the investigation process, scientific study, experimentation, research study, and of course, we need to add a cost analysis. Under what situation or condition to do these latest concrete technologies are applicable? Sa present, dito sa Pilipinas, we have the Build program of the government. And saan ba pwedeng gawin yan? Sa global warming situation natin. And that's all for today. Thank you and God bless.